So I'm Anthony Kazub. You can Google me at kazub.com. That's my official website. Also, like.audio is another official website. So my email address is quite simply I@like.audio. So I'm a bit of a nerd. I am a third generation broadcast engineer. I am recently just laid off from the Canadian Broadcasting Corporation. So a rite of passage in broadcasting is a good layoff. I'll be happily able to tell you where I've landed once the dust has settled. But I assure you, yeah, things are going to be good. I'm going to talk today about not my grandfather's workbench. This isn't my grandfather's workbench, but this is kind of what I typically grew up with. Just a single little I'm going to call it a manual oscilloscope and a manual function generator. That's kind of where it started. And when I went to college, we had the same kind of thing. It was a manual voltmeter and a manual oscilloscope and a little bit more high-end kind of spectrum analyzers. And I always thought to myself, like, hey, is there a faster way to test a mixing console? Because maybe you know, maybe you don't, but I'm obsessed with vintage mixing consoles, specifically Wardbeck mixing consoles. And when I worked for Wardbeck, I started exploring some of the things I learned in college, how to automate test and measurement, how to automate measurements, how to automate system testing. And I started going through, I have this kind of rule in my life. It's if you want to learn a new trick, read an old book. And the other trick is I don't trust any documentation if it's in color. I don't know why that is, but if it's in black and white, I believe it. And one of the things I found in the back of an HP book was this monstrosity, which is it's a multiplexer. You can put power supplies into it. You can put your coax into it. You can put your analog into it, and you can talk to it with these amazing HP calculators through this thing called the HPIB. Show of hands, thumbs up if you've ever heard of HPIB. Anybody? And I can't really see hands, but just right? It's this kind of like 1970s technology that people forgot about, but I found it to be extremely interesting. And take a look at this guy here with his interface module for measuring system and his interval probes. And I'm like, okay, I want to be this guy. I want to figure this out. So I had something I wanted under test, and
It's called now GPIB.
GPIB. That's old.
It is called now GPIB.
It is well, it's actually Visa if you want to get into it, or IVI.
Okay.
We'll get to it, Willie. We'll get to the history of it, but I was specifically talking about how the history of it comes from HP. So it's an IEEE standard. It's IEEE 488, and it is, like Willie said, a very versatile thing that has become common. So hey, well, on that note, we are one person that knows what the hell I'm talking about here. So that's good. Thanks, Willie. Appreciate it. So I wanted to automate some of my stuff. So the goal was for me to have a mixing console. I had outputs and I had inputs, and I had a lot of them. You can tell by the size of these EDAC 120s that each one of those is 12 channels in, 12 channels out. So I set up with my wife. I promised her no electrical fires, but I needed a few breakers. So in my garage at home, I started developing my GPIB lab. I had bought one of those HP, it's a multiplexer. This is a power supply. So this power supply is actually 8 power supplies in one frame. And I set it up in my garage. So this is what it looked like at a point in time. And all of these devices were on a GPIB network. Willie, thank you. And that GPIB network was, it's a serial, it's actually a parallel serial communication. So each wire daisy chains from one device to the next, to the next, to the next. So you can only have so many devices on the network. And then COVID hit, so I got to reorganize stuff, and I got into, you know, digital multimeters, scopes, signal generators, IVI type of instruments on the LXI bus, right? So GPIB kind of grew into LXI and various other things. So this is just the front part of my garage. On the other side of the garage, I have my machine shop. I have a mill and I have a lathe, and I have three-phase power in the back, and I do sheet metal work on the other side. So I started connecting these multimeters. I started connecting these oscilloscopes. I have DC loads, so I used to restore power supplies. I still do, but I needed a plus voltage and a minus voltage to apply a synthetic DC load to the power supplies to test their current draw. I have spectrum analyzers. This is a CDMA test set. Doesn't really do anything. I have my own vector network analyzer. This is all my garage, by the way. I used to have, so I still have this Wardbeck VU meter. I think I still have some of this stuff. I think I sold to Bryston, for booze, maybe a couple of beers. Distortion analyzer, all that kind of stuff. So inputs and outputs. I started hooking up this chassis of multiplexing, and it has buses. I started wiring all of this stuff. I started connecting the inputs and the outputs. I started building snakes for it. The coax module has a whole bunch of stuff. I did all the engineering for all of this stuff, and it just got out of hand. Let me just tell you, it just got out of hand. Then I got into designing the software for it. So what I designed was a sequential timer. So this is test cycles. So because you can't talk to everything all at the same time, you can only talk to one device kind of thing at the same time. You kind of put out a command, you get and set, very much like an SNMP. Like think of this like SNMP. So I say, okay, go get this value from the DMM. I want to log the measurements from the DMM. And then I just had this timer that just kind of rolled around. So I created full automation software for this. I created, controls for my power supply. This is all from scratch. It's all using Visual Studio. But today we're going to talk about something different. I designed my own oscilloscope software. I designed my own routing software. I did crazy things. Like, let me just tell you, I did some crazy things. I started designing my own bar graphs and designing my own matrix and my own. Anyway, it just got a little crazy. It just got a little crazy, and that's kind of where we are today. And today, what I'm going to talk about is this project that I'm working on. You guys can see this here. So what I've got going on here is kind of a continuation of all of that, but it's a modern twist to the GPIB stuff that I was working on before. I had a colleague contact me and say, "Hey, Anthony, I got this spectrum analyzer, and I want to do a venue audit of the RF spectrum. This is the SBE, so we can talk about spectrum here. You all know what I'm talking about. You're here, aren't you?" So what he does is he's a RF microphone coordinator. And what he gets into is hold on, give me 2 seconds here. My kids are knocking on the door. What he gets into is big shows that have upwards of 70 microphones to coordinate, 70 RF microphones to coordinate. He is now starting to deal with 900 megahertz stuff. He's starting to get questions about monitoring the RF of Wi-Fi. He's starting to care about wireless cameras, et cetera, et cetera. So his spectral interests are growing. But what happens is he was hired out to do a survey. So what he had, and I'm sure you all have had this experience, he goes out with a spectrum analyzer. He types in a bunch of numbers on his spectrum analyzer, hits scan, waits a couple minutes or an hour for it to settle, saves that file, goes to the next band, goes to the next band, goes to the next band, and does that a couple of times. So what he asked me to kind of hypothesize was, well, how do I do that automatically? And I said, okay, well, I can do this. I can like I can really do this. So I needed an excuse to learn Python. Don't we all need an excuse to learn Python? There was a library for the GPIB. I'm just going to call it Skippy commands. So Willie, it goes deeper. The rabbit hole of HPIB and IEEE 488 goes deeper. So there are Skippy commands that are available for PyVisa. And of course, we're in 2025, and I'm done writing code by hand. Let me tell you, I'm done with it because we have this Gemini thing. We have ChatGTP, and I'm going to give you an example of how I have been using, and this we'll go deeper. But what he asked me to do was, okay, I want to. This is version 2 I have on the side here. It started off as a 100-line piece of software. So I'm just going to walk you through the prompt. I apologize if I spell poorly. Just follow me in this thought process. A really good computer engineering teacher of mine once told me is if you can define the problem properly, you're halfway to a solution. So imagine a Python script that uses PyVisa, and that's the command for the API that we're using here. The script should scan. Let's do. We got some radio engineers here, so let's go 88 kilohertz to 108 kilohertz in one. Let's go 1,000 hertz increments, RBW, then it should write it to a CSV. Okay, so it's just like this. This is literally this is literally the text message my colleague kind of sent me, and that's really what he sent me was like, okay, look, imagine if I could talk to my spectrum analyzer and get a CSV out of it. Okay, so yeah, I could go back and engineer my stuff, but look, I've got 100 lines of code. Okay, let's try running this. So what I'm going to do is this never works properly, folks. Just so you know, like live programming demonstrations, this is a skill. Okay, so I just literally grabbed a piece of Python. I wrote it in GPT. I'm going to save it as what is this? SBE demo dot py. Okay. So one of the things, all of my GPIB addresses, there's a very specific IP address for it. I have my own domain and my own DNS here, so 44.164. Let's just pretend I knew that. So it's going to connect to my Spectrum Analyzer over IP. All right, so I'm going to save that. Folks, you saw me make the prompt. You saw me do everything there. Okay, look, I got an error. All right, so I'm going to put that error into the Gemini. And the Gemini is now going to say, oh, hey, Anthony, looks like you're running into a common issue. Pip install PyVisa. So it says, oh, okay, well, what you need to do is you need to install a package. Oh, okay, cool. So I'm gonna install that package. That package is requirement already satisfied. Oh, look, a new release is fine. Okay, install, and let's do. You kind of get into it, and you feed the language into the other things. So I'm going to feed that back into Gemini. Okay, so Gemini says, oh, okay, well, you did this. Okay, cool. It seems like you've already installed PyVisa. Okay, looks like it's good. Okay, when the program is done, open the CSV file. The CSV file should be called sbe.csv CSV. Oh, look at this thing even rhymes before you get into it. Okay, so now look, I've already generated version 2 of my software. But I made a change here, right? So this is my Visa address, and I know that I've made that change already. So I'm going to feed my Visa address, and now in this conversation that Gemini and I have, this conversation is growing to the point where, okay, now it knows that I've changed this. Okay, so here's the SBE. I've made 3 prompts. I'm going to hit OK. No module named Visa. Okay, let's take a look. So no module named Visa. So, oh, here's the problem. It's actually Pi Visa is the module. I'm gonna hit OK. I'm gonna hit Enter. Trace back. Okay, did I mean Pi Visa? Okay, right. So here I'm gonna paste that into Gemini. Look, I don't know anything about Python. I haven't written a single line of code. Hey, Anthony, I've reviewed your new error. Boom. Oh, look, it was supposed to import Pi Visa as Visa. It made its own mistake. Okay, so let's go back to the demo. We're gonna go paste. I'm gonna go run again. Hey, look at that. It's connected to my spectrum analyzer, and it's now going through. I can see my spectrum analyzer doing some stuff on the side here, and it has now created a Pi Visa for me. Let's see, where did it end up? Oh, a Visa error occurred. Okay, look. Now I'm going to take that error and I'm going to feed it back in here. So within like 10, 15 minutes here, we're going to have a working Python script to connect to our spectrum analyzer. Okay, so 4464. Okay, so actually I know exactly what's wrong here. So I've got another piece of software running here. This is the typical engineer's problem, is you've got like 40 things accessing. I'm going to cancel this, close this, go to this one. I'm going to try it again. With the spectrum analyzer, look, it actually shows you, I can actually see the commands talking to the spectrum analyzer. These are the GPIB commands. So it opens the instrument, it connects to the instrument. Okay, so there we got another result. Okay, so here it goes. Let's let me do that demo again. Okay, let's see. Okay, Visa IO error occurred. Okay, timeout before there. Okay, so now I'm going to take that error. I'm going to feed it back in. Okay, feed it back in. So nothing happened on the spectrum analyzer. Put some debug information into the program to see what steps are being made good and bad. I'm just talking to it like a 5-year-old. I'm saying to this thing, look, I want you to rewrite this program again and again. I'm still under 100 lines of code, and yeah, I'm not saying programming is going to die or this is like an easy way out, but I'm just saying, like, look, let's iterate here, and let's an unexpected indent. For those who love Python, the unexpected indent is your frenemy. Okay, so here, poof, run, save. Okay, look, querying instrument with measure. Okay, all right. So it doesn't know the proper commands, right? So I know that this is not the right command. So what I'm going to do is I'm going to go to, because I'm a nerd and I have access to these things. What I have is I have the manual for every one of my instruments. Okay, so I'm going to go to instruments that I've owned. I have my spectrum analyzer, and I have a programming guide. I'm going to literally drag the programming guide here and say, I think the commands used are not the ones for my spectrum analyzer. Check out this manual for proper commands. And this is, I'm just using this as an example to be like, look, you can take your documentation, your API documentation, just something that the vendor has provided for you. The vendor provided me this programming guide, and I'm taking this vendor supplied document. I'm not going to read it. It's 390 page. Hey, Anthony, thanks for providing this programming guide. The N9340 is a crucial piece of information. After reviewing the manual, it's clear that they were generic and not specific to your unit. No wonder it wasn't working. So I'm going to copy that again. I'm going to throw it into my SBE demo file, paste. Okay. Oh, my spectrum analyzer is doing crazy stuff over here, and it's calculating marks, and it's doing stuff. Oh, I got an error. And again, I'm going to iterate, and I'm not saying, okay, like I have a computer science background, so like I'm not saying this is the right way to do things, but for somebody who is afraid of getting under the hood of software, this is a very quick way to start getting into things. So here it's saying, oh, hey, I did that wrong. So I'm feeding, it's a large language model. So it needs language in order to learn about what's going wrong. Okay, so here let's, and just like a car, we're going to set it. Oh, see, look, it's actually querying my spectrum analyzer, and what it's doing is it's getting those maximum values. Look, I'm at 88.4. So within a matter of, I don't even know, this presentation's been 30 minutes, less than 30 minutes. So in a matter of, I don't know, call it less than 30 minutes, I have successfully prompted and created something to talk to a very specific, bespoke piece of software. I've also created something that's running, something that has debug, something that has error checking. Like it's actually getting me the values of 88.179, and I'm like, okay, all right, this is too precise for me. Okay, let's go back here. I take the debug message, I put it in there, too fine of resolution. Let's do 5 kilohertz increments instead. Okay. And I'm sloppy typer. I don't even care. You drink a couple beers, it gets quicker. And this thing, it's a large language model. It knows what to do and how to be better at that. So it knows, like it does an error check before you even start. So I'm going to do that again. Look, it's restarted the command, and it's doing 5,000 kilohertz increments on that. Oh, but look, it's actually 88.1 megahertz. Oh, yeah, okay, cool. Um, anyway, that was a quick demo of like how fast uh, beerware is yeah. Actually, so when I worked for CBC, we couldn't call it software, we couldn't call it application development. I called it scriptware. And scriptware is kind of this like hybrid between a piece of software and an application. It's this scriptware. Beerware is good. Napkinware, that's also a colloquial term for this stuff. Okay, so then let's say you now have the like this Python script is running in a console. I don't really want that. Okay, this is cool. Can you add a user interface that gives me a text box for start, end, and RBW? Plot the output of the CSV file on an XY graph. The X is the X is frequency in megahertz, and the Y is dBm amplitude. The Y max should be 0 dBm, and the Y min should be negative 120. Okay, so within a matter of I don't even know how many prompts I've done. Let's say 5, 6 prompts, maybe 10 prompts, plus a little bit of troubleshooting, trust a little bit of thing. Okay, Anthony, here, that's a great idea. Creating a user interface will make the script much easier. And it's like, yes, of course. Oh, it's doing it in HTML. Why is it doing it in HTML? It's a web application. Ah, no, no, no. I want it to do, no, no, no. Stop, stop, stop. Look at that. It created a web application for me to interface with my scanner in seconds. Like, I didn't program a single line of code, and look, it even used nice, cool colors. Look, start frequency, end frequency, step increment in kilohertz, and look, is that a graph that's being generated? Holy schmoly! Okay, let's put all that in the Python script and use. I know about this library. It's called tkinter and matplotlib. You kind of get better at at doing this stuff here, but it wrote 1,000 lines of code by accident of things I didn't want. Did you see how fast I threw away that iteration? The beauty of this iteration of software development, like it's really truly falls into the agile methodology with like you can just throw it away. Okay, so now I'm going to go back to my my thing here. I'm going to paste my Python script and I'm going to run it again. And lo and behold, I have created a full-blown application in less than 30 prompts. Okay, so I'm going to start at 88. Let's just go to 90. Steps. Let's go 10 kilohertz, and we're going to go start scan. Okay, so I don't know if it's going to work, but my whole point is that here it is in a matter of 20, 30 prompts. You know, talking about the right things, it's very much there for us. Okay, so look, nothing's displaying on the screen. Check this out. Nothing is displaying on the screen. The values should auto update the graph. You know, I no longer talk to the software like it's lines of code. I talk to it now like, hey, look, look, I understand you're trying to update it real time as the suite progresses rather than waiting for the entire scan. Current approach to the design doesn't work that way. Well, I'll tell you what, you know, boom, boom, boom. 30 seconds later, I've got a new version. And look, I'm at 204 lines of code. And it's not just like writing code is cool and all, but like 200 lines of code is like that's a lot of code to write. Like I could not have factored that like as quickly as possible. Okay, start scanning. All right, let's see if it's doing its thing. It doesn't really matter if this works or not, but I think you all get the idea of how quickly you can iterate these types of pieces of software. Okay, before I move on to the next kind of thing, is that cool? Like, do you guys appreciate that? Like, I can't really see y'all. Y'all got your cameras off except for Ron, and Ron looks mildly impressed. Mildly. Anyone else? Yeah, David says, yeah, thumbs up. That's cool.
You're gonna make me unmute to get into this, but no, this is slicker than snot. This is awesome.
Yeah, it's really kind of it's really one of those like my communications teacher once told me, it's like, look, man, I'm just teaching you the keys to go in and like just unlock that little potential here. Okay, so what the hell is Anthony doing here? Okay, so let's open an old file. Okay, so this is scan v2. And I know this one worked. Okay, it worked at some point in time. But I wanted scan name. And the problem with software iteration is you can do it so quick. So we started iterating, and I'm like, okay, every time I would do a chat, I would do scan. Here's another scan. Let's see if we can get version 4.10.4 running. Okay, so here's version 10.4.2 running. And it started looking like this. Okay, so boom, I had a user interface. Can I connect to my device? Connected. Hey, look, it actually told me it's connected. Hey, look, I have this debug window built into the application now. Hey, look, it's writing the position. Here's the reference level. Here's all of this stuff. Okay, I want to open the folder. The folder doesn't exist, Anthony. You fool. Okay, so I'm going to apply these settings to the device and I'm going to start the scan. So obviously version 10.4 kind of had some issues with it. So I got into that old for those who've studied computer engineering, like the idea of like putting just a bunch of print statements in till you figure it out, like that's really what it's doing. But I'm taking the debug log and taking the code. Yeah, it's crashing. I'm taking the debug log and I'm taking the code and I'm constantly feeding it back into itself. Artificial intelligence is not the right word. This large language model, it needs language to process. Okay, so let's go back. I want to show you what the result of this stuff was. Okay, so we got pretty intense. I'm going to go open, and I apologize. You'll see 1,000. Release 1. I did release this. Okay, so I did do a running release, and it was used on site. Okay, and I'm going to open the folder. Folder does not exist. Let me just see. I apologize. Give me 30 seconds here. Spectrum Analyzer. I'm very much like y'all, like I have a bajillion files and I don't know where any of them are. So let's go back here. Spectrum, release 1. Is there data in here? Yeah, there is data in here. Okay, so I'm going to go, hey, just for those who didn't believe me, this is that sbe.csv that was created. And here's the frequency in hertz. And here is, so my little SBE demo actually worked. Just, I'm going to pat myself on the back. That actually worked. Okay, so I'm going to open this main, and I'm going to show you what the result of this stuff was. Okay, so he wanted to scan a whole bunch of frequencies. Here's a bunch of UHF stuff. We're going to set the RBW. I'm glad I don't have to explain what these are to y'all. Okay, here you go. So we're going to connect to the device. Here, I'm just going to, oh, errors. This is the problem with demos. Luckily, my machine is not in a building 1,000 kilometers away, because the whole thing about this was designed to be a remote thing. So when a scan is finished, what it generates for me now is it generates me a CSV, and the CSV generates a frequency in megahertz and amplitude in dBm. But it also generates me a HTML file. And this HTML file is actually a fully interactive chart. I want to be very clear when I tell you this, is I did not write any code for this. I prompted every request. With that program running, I included this thing called include TV band markers, include government band markers, open plot after each one. Okay, so with that, I've got all of these. Look, I've got on my spectrum, I've got little notes that say this is the amateur radio 70 centimeter. This is the public safety band. So when he's going out and about, he knows that this here is the GSM band. This is the public safety band. This is it. So again, look, I've got this little slider on the bottom. Now my CSV actually has like crazy value. Like there's this huge, like I'm not delivering a CSV anymore. I'm delivering a CSV plus this HTML file. Okay. So now I'm going to zoom in on that. I'm going to zoom in on that. I'm going to put my mouse over, and now it's going to tell me the exact value of that CSV that was generated. Look, it just literally did this scan while we were doing things. Okay. So here's this. And then I'm a data scientist, kind of by, it's a hobby. Now that I've done, instead of doing my one manual frequency sweep on my spectrum analyzer and saved it to the CSV inside that stupid spectrum analyzer and put it on a USB stick, I now have this many scans since we started this meeting. Actually, no, I started this at like noonish. Okay, so I started at 12:30. I started at 12:30, and I have scanned my spectrum 23 times. Well, the data scientist in me says, well, this big blue button that says generate average plot. Let's run that. That sounds like a good feature, Anthony. Okay, so I'm going to stop my scan because this is gonna overload a whole bunch of stuff. So now what it does is it looks into that folder. Again, I didn't write a single line of this code. This is all prompted. This is all. It looked at every one of those spectrum scans that I just did hours before the meeting, and now it has applied some statistical analysis to it. Okay, let's zoom out again. Okay, so I'm gonna just scan a little zone. Okay, so I'm gonna pay attention to this one here. Okay, so look how many data points I've got between this and this and this, and look if I again, this is all libraries that exist. Okay, so I'm gonna double click one of these. Let's see, this one. Okay, so this is one trace. This is another trace, and look, I'm turning on the traces in an HTML file. And if you want, I can send you a link to this file, and you can see how these traces pile up. And I can send this to my client. I can send this to the guy at front of house. I'm going to double click this again, and now all of them are going to go up. So now that I have all of these spectrum scans kind of stockpiled, look at this. Look, so I know that this little, look, that's TV 42 and 43. Well, I know because I've been an RF coordinator. Well, that's actually LTE now. And I could probably say with pretty high confidence that that is from the tower. But I've got these markers overlaid at this exact point where my marker is at this time of day at 12:39 and 49 seconds, it was minus 110 dBm. Okay. Then I get crazier. Okay, so now I'm gonna scroll vertically, and now I have a very different point of view of my spectrum. Okay, so in purple I've got my range, and in my blue I've got standard deviation. So I know now that this frequency has this much of a deviation or a range, and I may have missed it with a single scan, right? So I start tearing this apart, and I start looking at these things, and I go, hey, look at this. And again, I don't know how to interpret this data. I'm not an RF engineer like you folks. But I get into it. I'm like, oh, look at this. Okay, well, this is constant. This is constant. There's a little bit of noise here. There's some deviation here in this. Look, I may not have seen it on one scan, but on 30 scans, I start noticing these things. Here, look, it doesn't even, in one peak of, like, at this one peak, one of the scans gave me this. So the deviation actually kind of comes out to it. Okay, so it gets crazy. It gets crazy. Okay, now I'm gonna take you over to the new piece of software, and I'm gonna show you an extreme version. The last 10 minutes. This is okay. Grand finale here. So the piece of software I did, I call it open air because the goal is for it to be like an open source spectrum analyzer. And I got really good at working with Gemini. I got really good at working with LLMs and stuff like that. And what I do is I start from scratch every time. But before I start from scratch, I give them this prompt. Okay, like I got sick and tired. I got frustrated. So I say to him, "Look, Gemini. Okay, I've had some time to deal with you, and I'm like talking to the I'm talking to the computer. Look, I need you to follow some instructions. I pay money for you. You owe me. Address the user as Anthony. Reset your project knowledge. Maintain code integrity. Adhere to the facts. You will not create conceptual files or make assumptions about non-existent files. These are lessons I've learned. Provide complete files. You will be truthful. You will acknowledge, approve. Single file focus. Single files over 1,000 lines are a nightmare, I tell it. Provide the user with reminders. You remind the users to take a deep breath before compiling. Very important. You will remind the user to take a walk, hydrate, visit with family, show affection to your spouse. You will adhere to these debug style. And I give it a big, huge debug style. Here are the code style headers. I would like this style of file format and this version tracking. So every time I now create a piece of software, I would like the version to be year, month, and an increment of each revision with each GPT or Gemini session. I want to use this debug style. I want the debug messages to include the current file, the current version, the current function that it's in. So I actually want to know what function is making a debug thing. And then in my functions, I want you to debug log something about entering the function, something about logging the function. Okay, so now, and I ask it to swear at me. Like, you can use disparaging language. Like, I tell it to swear at me. I'm like, okay, fine. This piece of software got a little bit out of control. So what happened with these large files, like working with one file is pretty easy. Working with a lot of files, not so fun. So I created this using GPT, or I think, yeah, I used Gemini for it. I created this crawl piece of software. Just again, it's just this disposable application. And what it does is it goes through my application and it generates me a map of how my application is built. So I say to it, okay, look. Here's the file, the main app. It imports all of these things. It has all of these functions. The control logic has this import. It does this function. So when you get into like large pieces of software, like they get really, 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 really complicated. And then when I got into everything, I generated an everything log. So what it does is it takes every piece of Python code and it dumps it into one big file. So this whole project right now, again, I did not write a single line of this code. This piece of software is 25,000 lines of code. Murphy's Law says this won't work, but I'm going to run it. Okay, so here is what 25,000 lines of Gemini prompted code with computer engineering background looks like. Okay, all right. Okay, it's running. It's got a bit of a nicer user interface. Hey, look at that. There's a sash, right? So there's graphs. Okay, so now there's also a console. There's also a debug log. Okay, and these are things we take for granted as broadcast engineers. Okay, look, debug to terminal, debug to file, clear the debug log. You have to manually do all of these things. Okay, so I'm going to connect to the device. And because every spectrum analyzer speaks a little bit differently, I created this thing called Yak. I call it Yak because it talks to one thing and then talks to another. So it's Yak, and the function's literally called Yakety Yak. And so if my device is a 9340 CN and you need the sweep time, it actually has a Yak command that's dedicated to it. If you want to know the frequency, if you have a Rody Schwartz, if you have a key site, you have to speak this language to get to it. Okay, so settings. Okay, so here's the settings of my spectrum analyzer. I'm going to turn the preamp gain on. I'm going to turn the high sensitivity on. I'm going to turn all my markers on. I'm going to do a peak search, and I'm going to read the peaks, and all the peaks come back to me. I'm going to do markers. Okay, so here's markers. So my colleague uses a whole bunch of different pieces of software to do RF coordination. So Sure Wireless Workbench. So for example, Sure Wireless Workbench, you go and you, again, I just want to say it again, I did not write a line of code. This is all prompted code. Here's an import sample. It goes and it reads the Sure Wireless Workbench, generates my groups. Look, there's groups. This is inside a group. This is inside a group. This is inside a group. Moment of truth. Now it's doing a loop to get that marker. So he can touch a microphone or an IFB. Okay, he touches IFB 18. It centers my spectrum analyzer to 482.95. It displays on top here, it displays me my trace that's live. It displays me my max hold, and it displays me my minimum hold. And now I'm going to change the span. So I'm going to go to a span of 1 megahertz. And now the span of 1 megahertz has been applied to the device. I'm going to change my RBW to a steady 30 kilohertz here. 30 kilohertz is, it's a little low. Kind of, we're into the noise there. Right? You see how quick that is for him? Then I had to write my own kind of Excel spreadsheet. This is the feature I'm most proud of. Watch this. This is amazing. Okay, so Axient microphones. And I'm going to call this mic 1. And then I'm going to do this amazing trick. I call it paste plus 1. So I hold down control and I push enter, and it increments 1, 2, 3, 4, 5, 6, 7, 8. So I don't have to type mic 1, mic 2, mic 3, mic 4. I do a paste plus 1. So this is Shure in-ear monitor 1, control enter, monitor 1, 2, 3, 4, 5. Let's say I want to move these into a new group. I'm going to call this group, just for the sake of argument, this is the SBE group. And I'm going to move this one here into the CCBE group and go bang, bang, bang. And now when I go back to my markers, there's the CCBE group. Here's the SBE group. I select that microphone and now I'm scanning it. Okay, not a line of code was written by hand. There's a lot of troubleshooting done by hand, let me tell you, but not a line of code was written by hand. I'm going to go to presets, right? So on the device, there's a bunch of presets. So he wanted a whole bunch of things, it adjusts the max hold, it does a whole bunch of markers. I'm like, okay, cool. Again, there's a preset editor. So let's say you wanted to you had 10 radio stations you were monitoring, you could put that in the presets, you could do that. Scanning, I'm not going to go into that. I kind of explained that. Plotting, okay, this is where the plot thickens. Okay, now I'm going to open a folder for 3D plotting. Let's see if this works. Okay, release 1, spectrum analyzer, scan data. Okay, so I'm going to select this folder. It's going to say select the series of stuff there. And now I'm going to generate, God willing and permitted. Did it work? Did it work? Come on, did it work? I just want to say not a line of code was written by hand. Again, I just want to reiterate that. So this is now a 3D model of that RF spectrum that I just scanned in my thing. Okay, and it is now time in seconds from start of scan and the frequency. Look at that. Okay, I'm not just on the spectrum, I'm freaking in the spectrum here doing this stuff. Okay, I just want to say it again, not a line of code was handmade. This was all generated using Gemini and those prompt methods that I told you about. This piece of software, I got into doing experiments with it. I can calculate intermod, right? So if I want to calculate third harmonic, fifth harmonic, I can do that. I'm working on the ability to change the colors. It has a full JSON API. It has a full config.ini. So you can actually do like a full configuration of the initialization of the device. Okay, folks, that's really it. The software is called Open Air. And I don't know if I created it or if Gemini created it, but I know we created it together. But I have to say, for those who are curious to explore software and curious to explore this world, it has never been easier to be a software developer ever, period, full stop. That's the end of my presentation. I know we're at time. I can take a couple of questions, or you can just sit back and relax, and it's up to you.
One quick comment on it. The thing I see is it's really friggin' awesome. And like I say, I just whipped out C++ code to drive an SDR while you were chatting.
Hmm.
You still have to know the questions to ask. So the engineering background, and that's what I say, that's where it gets fun.
100%. Yeah, and
So
yeah,
it doesn't eliminate the job, it just changes your focus. So you're not sitting there writing and debugging lines of code after hour.
100%.
You're
Yes,
testing a product and creating.
you're really developing, and that's why I think it's very important to have these debug logs, and to have this feedback mechanism, because like when I'm anytime I do something, it is now going to tell me what it is, and I feed it back into it. But I had to know how to do that, Jeff.
Right.
And yeah, I'm a software engineer. Like I studied it in college, along with RF, and I was very lucky to study both in parallel. But now it's like having a team of 50 people working for me in the background,
Gonna
and
say
this thing works for me.
I studied both too, but it was machine language on a 68,000 microprocessor. So
Totally, totally. And now, like if like I say, if you're whipping out some C to plug into something, like yeah, it's never been easier. It's never been easier, and it's never been more frustrating, but it's never been less frustrating too, because again, you have to know how to talk to it, and you have to know how to describe your problem to it. But for anybody who's wanting to get into it, it's nothing but spiritual for me to be able to talk to an LLM like this and be able to get back such a concrete, usable thing. That's it for me, folks.
any questions from anybody else before we let Anthony go?
No, I was
No
gonna.
question. Oh, go ahead.
Oh, yeah, I was gonna just give support too. Like it's working with CBC. There's been a bunch of just new hardware and little things like that of just even making a quick script on using FFmpeg and having it into a watch folder. It's
Totally.
crazy to change and how you can limit. Like you, nothing is sorry. It's all limitless on your opportunities there. So like I've been running just little scripts like that, and that's been a game changer where you would spend like a week trying to figure stuff out over there. But if you can just start to fine tune it into, okay, do it straight into Windows Startup and then clock that way. No, it was great. And I really appreciated all this stuff there, Anthony. It was great.
Cheers. Yeah, I have a lot of code running currently at CBC that was generated by LLMs. I did a whole bunch of GPIB, not GPIO stuff. Like I wrote a thing to run the Dalettes, because the Dalettes need start, stop, and all that stuff. So I did all on Arduino. I have stuff like one of my major projects was CBC Music. So again, to your point about file management, like moving, renaming, doing API calls, much simpler in the world. And things like Python and things like Microsoft PowerShell really enable users very quickly to build something, throw it away. Like yeah, build it, throw away. It's so quick. It's so quick to do it.
Now, are you using Gemini as an add-on to a Google Workspace account, personal Workspace account, or how are you using Gemini?
So I don't trust any of them to really keep track of a big project yet. So what I do is I literally have Gemini kind of erase itself every day, and then I feed it those crawls, and I feed it those things manually. So I find the more data it has, the more it hallucinates. So the more it hallucinates because of the amount of data it has, the worse the outcome of the product. So I don't have it tied in. CBC, when I was with CBC, we were very much a Google house, so I did tie it in with a lot of that stuff. I have done a lot of that stuff with Gemini, tying it in. I used Notebook LM quite extensively when I was there. I'm a Google user. My previous company was a Google user, and the company before that was a Google user. So I've come really good with it. Gemini, I chose Gemini and I pay $26 a month for it. Like, intelligence is a utility now, right? So I pay 26 bucks a month for it because everything I have is on Google. Um, I don't know what OpenAI is doing. I don't know what Grok is doing. I don't know what some of these other folks are doing. Um, because I pay for Gemini and I pay for this, it's like I say in my prompt, my first prompt is like, I pay for you. You owe me. You owe me privacy. You owe me. You owe me. So as long as I feel like I'm authoring this software, I feel like it has to stay in a platform that you're comfortable with. And I've gone completely Googleized. I'm Googleized to answer that.
Well, not to sidetrack, sidebar too much, but you said the word privacy. Do you really think you're getting the privacy you're owed for that $26 a month? I'm just kind of curious what your opinion is on that.
Well, the interesting thing about this is it's an open source project, so I don't really care. But when it comes to asking stupid questions or that kind of privacy, I don't keep its history. So as soon as I log into Gemini, it's a fresh Gemini situation. Google may use it to do things with it, but I like to say that companies stalk you, but not STALK, but they STOCKU. You are not of any interest to them, but your data is a lot of interest to them. So you are stalked, STOCK'd by those companies, not stalked, STALK by those companies. So no matter what you do in a browser, you're getting your data stocked somewhere. So am I worried about it? No, it's an open source project, so I don't really care. It swears a lot. My program swears a lot. Like if you look in the debug code, there's a lot of F this and nuts to that and BS this. So I don't really care. And in terms of my personal privacy, when LLMs first came out and I was with the corporation at the SEEB, I said, "Hey guys, this is great stuff. I'm going to use this." And they're like, "What are you talking about, Anthony? Like GPT? What the hell is that?" And they said, "Whatever you do, don't put any data into it." I said, "Well, what do you mean? Like that's you know?" They said, "Don't put any confidential data into it. Don't put anything of that sort into it." 6 months later, they came back and they actually had a thing called Chat CBC, and it was our own internal chat LLM talker. Ironically, it was based in Finland because the data protection laws in Finland were much better. And then 6 months later, and when they announced Chat CBC, you know what they said was, put everything in it, like everything, put everything in it. I want the Confluence in there. I want all your manuals in there. I want everything, put everything in it. And then 6 months after that, they got Gemini, and everything was Gemini. And if you look really close, all of that stuff is protected by the agreement you have. So even a corporation like the SEEB dealing with Google still has protections that are really strong. And it's really not a good business strategy for anybody to steal your data and secrets. But it's okay for them to stalk you, STOCKU. So anyway, that is a tangent, but I'm glad you asked.
Wow, that is a way more comprehensive answer than. Yeah, that was a way more comprehensive answer than I was expecting. A lot of context there. Thank you for that, and thank you for a lot of us were aware that this sort of thing was available and possible, but you've sort of walked us through the first steps that I'm sure many of us are going to follow up on.
Yeah, you can fail fast, and it's cheap to fail fast with this stuff. So I highly recommend you do it. Highly recommend it.
Cool. All right. Well, thank you very much. And my one takeaway from everything related to IT as a rule is if you can't figure out what the product is, it's you.
Yep.
So
true.
I appreciate that very much. Thank you, Anthony. That was excellent. With your permission, this because we record this, we'll strip off the boring chapter business at the end and save a recording of the video. We typically post it on sbe100.ca, but I'll certainly reach out and ask you if that's okay in an email.
Yeah, it's okay. And can it be public? Like, do you have a YouTube channel or like what?
Yes.
What do you deal with it? Yeah.
Well,
okay.
and I mean,
yeah.
SBE100.ca is open forum. Anybody can access the website.
Okay.
So,
yeah, absolutely. Yeah, absolutely. One more plug, like.audio. If you want to know what I'm up to, type like.audio. And I also have a YouTube channel, believe it or not. It's about machining and all that stuff. It's also called like.audio, DOT audio. So please, I gotta plug myself, shameless self-promotion. Yeah.
Bring it on, man. If nobody else is promoting us except us. So there you go.
Exactly.
All right. Well,
all right, folks.
Thank you very much, Ad.